Okay, so for this quick video, we want to find the derivatives of these three different functions using the power rule. And it's always a really good practice to express each of the functions using exponents. So let's first start off with f of x. F of x we see up here is 5 divided by x cubed, which is the same thing as 5 times x to the negative 3 power. So in finding the derivative using the power rule, our 5 will be multiplied, our negative 3 will come down out front, and then our power is going to drop by 1 in our exponent. That's going to make negative 15 divided by x to the 4th power. We now move on to g of x. G of x is initially written as the cube root of x. Well, we know that's the same thing as x to the 1/3 power. So for its derivative, we're going to have our 1/3 come down out front as a multiplied coefficient, and then subtract 1 from the exponent. So that's going to be 1/3 x to the 1/3 take away 1 is 1/3 take away 3/3. That is negative 4/3. We now need to rewrite this using our fraction notation and our radical notation. So this is going to be 1 over 3 times the cubed root of x to the 4th. This does simplify further as 1 over 3x times the cubed root of x, but keeping it in this other form is perfectly acceptable. But again, very important to be consistent. If it starts off as a cube root, it needs to end up as a cube root. We don't want to have other roots in our answers or have other just fraction notation. Last up, we had h of x, and that was defined as 1 over the square root of x. As we write that using the right notation, that is x to the negative 1/2 power. 1/2 because it's a square root, negative because it's in our denominator. Finding the derivative, h prime of x, that's going to be negative 1/2. Again, that power comes down as a coefficient. And once again, we have to drop the power by 1. So that's negative 1/2 minus 1. That's the same thing as negative 1/2 times x to the negative 3/2, which comes from taking a negative 1/2 minus 2/2. Writing this, it's going to be negative 1 over 2 times the square root of x cubed, which of course simplifies down to negative 1 over 2x square root x. So we found our three derivatives using the power rule, and again, cannot stress enough the importance of being consistent with notation. If it starts off as a rational expression, it needs to end as a rational expression. If it starts off as a radical, it needs to end as a radical. And if it starts off with fraction notation and radical notation, it needs to remain that way for a final answer.